So our main goal today is to just read a few application problems. Um, Cohort A had done a few of these when I'd seen you at the beginning of the week. Cohort B, you haven't seen these yet, so I'm just going to help you. So I'm always going to help you set up the triangle anyways, just, I don't know, because life, right? We're just trying to get to vacation here. We're not gonna be too crazy. So for each problem, I will help you set up the triangle. Our main goal is the first thing you always want to do is draw a sketch because that's going to help you visualize what the heck you have. And then we're going to set up an equation and solve it. I do have a calculator with me. I'm obviously for these ones going to kind of do the workout with you, but you will need a calculator when you're doing a few. The one on your phone should be fine. So just as a heads up. So we have a 15-foot ladder. So I'm going to do number one here. We have a 50-foot ladder leaning against a wall at an angle of elevation of 60 degrees. Okay, so we have a wall. So let's say I have like a building here, whatever. We have a ladder, right? So it's going to look like this. We have the ground. Okay. Every time we should have a right triangle. So just as a heads up there. So I have a nice right triangle. It tells me the ladder is 15 feet. So this is my ladder. So this side is 15. And it tells me the angle of elevation. Elevation is when you look up at something. So this angle going up is 60 degrees. Okay, so I have a this little triangle going on. It asked me two questions. How high up the wall does the ladder rest? So this is the wall, right? And I want to know what that height is. So I always go back to what I know about triangles, and that is labeling. Labeling is our friend. It makes our life easier. So from the angle of 60 degrees, I know the hypotenuse, and I need, what would that be? That would be opposite. Okay, so hypotenuse, opposite, we think in our mind. So, and then once I have that, I say, oh, I'm using sine. Okay, I feel like we've done this at this point a million times. I'm kind of at this point over solving triangles because I do it 4 times, or I do each lesson 4 times. Now I only get to do it 2, which is exciting because my cohorts are together. So I'm going to set up my equation. So when I think of I think of the equation that sine of the angle equals opposite, which is x, over hypotenuse, which is 15. Oh, that's not too bad. So then we just need to multiply both sides by 15 to solve. I'm throwing that into my calculator to find my answer. And my x comes out to be, I have no clue, so I'm grabbing my handy dandy calculator here. 15 times sine of 60 is 12.99. So let's just say it's 13. So that would be 13 feet. And that's for part A. So I'll just remind myself the wall is 13 feet high, or it's a height, whatever. I guess the wall is 13 feet, but you get the idea. It's up to the wall, 13 feet high. Okay, so that wasn't too bad. I always like to kind of label my triangle as I go, especially since there's more than one part here. So this is 13. Okay, so let's do B, but B is going to be pretty quick because it says how far from the wall is the base of the ladder. So when I'm looking at the base of the ladder, that's just the third side. And once again, you can label it A, B, C if you want. Just make sure C is always your right angle. It doesn't really matter. So I'm going to say, call that A squared. B, sorry, awkwardly written there. A squared plus 13 squared equals 15 squared. Just make sure the C has to be 15. The A and the B don't really matter, so you can kind of label it how you please. But then we just do a quick solve here. Once again, I have no clue how much that is. So 15 squared minus 13 squared comes out to be 56. And I'm going to take the square root of that. So the square root of 56 is 7.5, we'll say. So it's 7.5 feet from the base. And then I would be done with my problem. Sorry, I'm kind of writing in an awkward angle there, but we'll go with it. You can still read it. So I'm going to give you a minute. And as always, I know that half of you are probably trying to write this whilst in bed. So I'll give you a second to copy that, but I do expect to see that. Let's check in with a few people. Please pay attention here. So once again, if I kind of check in with you, sorry, trying to find something here. You can either write in the chat or you can just say like, hey, Mr. Birdie. I'm gonna. I kind of like this. It's like a fun little surprise. So I'm gonna call on. How you feeling? I don't even know who's here. Okay, so some people might not actually be here, but we'll go with it. And then I know who to mark after. Let me check in. How you feeling, Adam? You good?
I'm doing great.
Oh my gosh, what a delight. Nice to hear it. How about you, Bridget? Oh, fabulous. Thank you. I'll just call it to you. Sorry, I'm just gonna make sure you guys are awake. How you doing, Matt?
Good.
Oh, fabulous. Does anyone have any questions, by the way? I know the last thing you want to do right now is ask questions on math, but I'll offer it. Okay, so let's move on. I'll be calling. I might be double calling some people. Don't think you're called on and you're good. So thank you for participating in This is Torture for some of you. Okay, so that's our first problem. I'm trying to see what time it is. I haven't used anything for that. Okay, so we're good. We're only a few minutes in here. So we only need to do two more problems. Yeah. Okay, so next problem. I'm going to skip around a little bit. I'm just going to fold my paper here so I can actually have it at the top. Okay, so number two, and I'm actually going to skip the number, but we'll go. Number two. We have a 50-foot pole has a support wire that runs from its top to the ground with an angle of depression of 75 degrees. Okay, so I need to draw what's going on here. We have a pole. Okay, I'm just going to draw a line. It has a support wire that runs from its top to the ground. So we have a wire here, and it's going to run to the ground. Okay, so that's not really that exciting, but if you want to label, this is the pole, this is the wire, like little things like that. This is the ground. It's just more to help you visualize what the heck's going on. The pole is 50 feet. Okay, so we know this is 50. The right angle. And it tells me the angle of depression. I talked about this with cohort A, but obviously cohort B I didn't see you. So whenever you have an angle of depression, when you think about something that's depressed, it goes down, right? So when you have an angle of depression, it's actually outcut. It's kind of weird because from here, it's this angle and it's outside of the triangle, which is kind of funky because that doesn't really help you. So what you can do is this angle and this angle will always be the same. You can always just put that angle there. Okay, so we have everything labeled. We have our angle. We have that side. How far from the base of the pole does the wire connect? So we're just trying to find this length. So we'll call that our x. So from the angle 75 degrees, what do we know? We know opposite. We need adjacent this time. So I'm thinking TOA in my head. But once again, I'm sorry, I'm writing it with the angle. Right. Try to put it at the angle I'm writing at, so I'm not always writing sideways for you. So I'm going to set up my equation based off TOA. That tangent of the angle is going to equal opposite is 50 over adjacent is x. Okay. So this one I do have to do two steps to solve it, which is kind of annoying, but life. We're going to multiply both sides by x. We have x times tangent of 75. That's going to equal 50. And then I'm going to divide both sides by tangent of 75. Oh, shoot. Oh, you have no idea. Okay, I'm like, am I recording this? But I am. Using my mind this morning. So this is what I'm throwing into my calculator to find my answer. So I grab mine. 50 divided by tangent of 75 is 13.4. And that is feet. So that's my answer for A. Okay, I'll kind of give you a second to stop. I keep us putting things over angles. All right. And now let's do B. And then there's just one more thing here. So for B, I'm going to kind of move it up a little bit, but how much wire is used? So basically, we need to find this. You can call it whatever you want. If you want to call it X again, or you can call it Y, or you can call it W, whatever makes sense for you. But once I notice that, if this side's 13.4, I can just use Pythagorean theorem. I don't need to go back and do all those steps again. So Pythagorean theorem, I have the two sides. I'm finding the hypotenuse, so I'm finding C. So I'm just going to throw in 13.4 squared plus, sorry, that works. There we go. Plus 50 squared equals C squared, or whatever you want to call it, W squared. I'm just grabbing my calculator and computing that. So C squared came out to be 2679.56, and I'm taking the square root of each side. And the square root of that is 51.8-ish. There we go. One thing, I'm going to leave that up for a minute. How you feeling, Connor? You doing good? Oh, how are you today? I'm just excited for life today. Thank you so much. Sorry, I'm just randomly calling on people. Katie, how you doing? Oh, good. I sound a little tired. Should go back to sleep later. Taylor, how you feeling? Oh, you guys are so nice for responding to me today. I'm really loving life. Okay, thanks, guys. I'll just call a few people as I go. So thank you for responding. I know you're alive. That's always a good thing. Guys, I think some of you sound like you have more energy than when you're actually in my class. So this is exciting stuff. So I'll leave that up for one more second. Then we only have one more problem. I might actually show more feeling you and only give you one wrap up. We'll see. That's that. My paper. I know it's a waste paper. Okay, so I'm skipping number 3 for now. You guys are actually going to try that one on your own in a second, and I want to do number 4, and then that's the last one we're doing together. So, thank you for bearing with me, being tortured. I know I'm with you. It was raining here before. Okay, so number 4. Jamie is 68 inches tall. Find the length of her shadow if the angle of elevation of the sun is 30.2. Sorry. Okay, so think about, we have a person. Okay, as you can see, I'm an artist here. So she is 68 inches tall. Okay, so we know her height. And then when we're talking about shadows, the sun comes down, its rays come down, it hits the person, the top of their head. And then the shadow is on the ground. So your shadow is down here, right? So these are the sun's rays. They hit you. Your shadow ends up on the ground. Depending on the time of day, sometimes it's super long, sometimes it's super short, because it all depends on the angle of the sun. So it says find the length of her shadow. So that's going to be the x that I'm finding if the angle of elevation of the sun is 30.2. So this angle right here would be 30.2. Okay. So we know these steps, or I hope we know these steps, because I feel like we've been doing this forever. I'm excited to move on after vacation, I'm going to be honest. So the step is from the angle 30.2 degrees. You know, sorry, that was kind of awkward. Let's get the angle. This is 68. Sorry, I put it in a weird spot. So we know opposite. We need adjacent. So we're going with good old TOA. Okay. So my equation is comes from TOA. Tangent of the angle equals opposite over adjacent. Okay, so kind of like the other one, we have 2 steps to solve it. I'm going to multiply both sides by x. Once I do that, I'm going to divide by tangent of 30.2. And then that cancels. I'm throwing this side into my calculator, and then I will be done. I kind of like that one. It was only 1 step. That's why I chose it. And it comes out to 116.8. It's a really long shadow, so that means the sun's really low in the sky. That makes sense at an angle of 32. Well, I guess it's only And that, my friends, is our last problem. Well, the last problem that we're doing together as a day. Corey, how you feeling? Corey?
Good.
Oh, gosh, sorry, I thought you weren't there. Okay, thank you. Darren, how you doing? Oh, love it, love it. I'm loving the music in the background. Do your thing. There you go. Casey, how you doing? Thank you. How about Caitlin?
Hi.
Hi. How you doing today?
Good.
I'm good, thank you. All right, thank you guys. You're being good sports today. I appreciate it. Um, I know there's a few more people. I will be checking in with you in a few more minutes. I don't know if everyone's actually on today, but we'll go. So those are the problems I wanted to do with you. What time is it? You know what, guys? I'm going to show you mercy. It's snowing. You're tired. I'm going to have you do one problem. I was going to give you two, but we'll save the other one later for fun. Okay. So I'm going to help you set it up. I do expect you to do the rest of the work on your own. When you are done, um, just in the chat say I'm done, and I'm gonna ask you, are you going to just put your camera on and just like show me your notes quick, or do you want to email it to me? You cannot get off until I have the email. Because let's be honest, some of you are gonna say, yeah, I'm sure I'll email you, and then I'll never get it. If there's a technical issue, just let me know. I understand. Um, but that's kind of the thing. I want you to be marked off for today before you leave because we know sometimes it's easy to say like, yeah, I'm gonna do it later, and you're not gonna do it later. So I'm gonna try to force you. Hopefully, this will actually boost some people's grades, so I'll force you to do the work. Okay. So here's the problem you're gonna try. I'm gonna set up the triangle with you, just to sketch with you, and then you're gonna try to solve it. So we have a plank. Oh, excuse me. We have a flat 12-foot plank is resting with one end on the ground and the other end on a ledge. Okay, so nothing fancy here. We have a ledge. We have a plank of wood. It's coming down. That's on the ground. Main goal is you really just need a right triangle. Is that weirdly low, but we'll go with it. Okay. Navigate on my table. The plank is 12 feet, right? This is the plank. So it's here, it's up here. So the plank is 12 feet. Okay. The ledge is 4 feet. So the ledge is over here. Ledge over here. That's 4 feet. Okay, so then it says for A, you guys are going to be finding this. How far from the base of the ledge? How far from the base of the ledge is the far end of the plank? So you're trying to find X, right? From the ledge to the plank, what is that? And then B, what is the grade? That's just a fancy word for what is the angle. So what is this theta? So I'm going to remind you. For A, I'd probably just use Pythagorean theorem. This is going to be your C, right? Because this is your hypotenuse. It doesn't matter which one you label A or B, but you're just going to find one. And then for B, you're finding an angle. So just as a reminder, you can really, once you have all three sides, you can use any trig function, but you are going to have to use an inverse trig function. I'm going to leave that up. I did a bad job of writing on my paper, but you get the idea. Let me check in with a few more people. Natalie, how you doing?
I am actually excited because of the snow.
Oh yeah, because you have you ever really seen snow?
No.
Oh, we'll go outside later and have fun. It's fun to play in snow. Good, that's a good thing. Well, have fun today. Damani, how you doing?
Good. How are you?
I'm good, thank you so much. How about Jordan? How are you?
I'm good. How are you?
Thank you. I'm good. How about Elise?
I'm good. How are you?
Good, thank you. Okay, I'll do the other two people in a minute. For now, we're just going to do this one problem, Natalie. So we'll just focus on this one. I think, yeah, I'll be nice. We're only going to do one today. I didn't know how long things would take, but I want people to have a few minutes here. So in the next few minutes, you are trying this one. Technically, it's three. We kind of went out of order, but you know the deal. It's technically our fourth problem. So can you find the missing side? Can you find the missing angle? when you are done in the chat, you are just gonna say, hey, look, I'm gonna um, just say I'm done, and then just tell me, are you going to email it or are you going to just show it to me in the meet? So whatever one works for you works for me. I know some people's cameras aren't working, and maybe you can scan on your phone type deal. But the main goal is before you sign on for today, I need to see that. I will mark you off for the day, so you will be all set with me. And then once you have confirmation with your name from me, I have to say your name, you are all set, then you can sign up. So I'll give you a few minutes. Once again, I have my chat up on a different screen here. So I'll be watching that when you're done. And I'll check in on you. Actually, let me check in with the last few people here. Christine, you there?
Yeah,
Okay, good morning. Thank you. How about Danny?
I'm good. How are you?
Oh, hey, I'm just great. Thanks for asking. Marcus, you there?
I'm here.
Hey, Marcus, thank you. How about Lexi?
I'm here.
Good morning. Hi, Lexi. And Chris. Oh, I got everyone, guys. You all showed up. Oh, my heart. Okay. Oh, okay. So I'm just gonna go in order of when people did it. So Connor, you're done. Do you want to show it to me on the screen, or are you gonna email it to me? Connor White. Oh wait, sorry, I can't see. No wonder. I'm sorry. That's my fault. I'm yelling at you, and I can't see. Hold on. I'm gonna stop presenting. Okay, give me 1 second. I just wanna No, it's fine. It's fine. Don't, because it's easier to just do it now. It's more. It's my fault. I can't see because I'm sharing my screen. So I'm going to turn off my recording.